Right, hello. Today we're going to be looking at quantitative aspects. And to first understand quantitative aspects, we're going to be first tackling the mole, right? So in quantitative aspects, moles are the most important, I would say, unit that we look for in quantitative aspects. It's what is asked the most. And because we have the mole, we can solve for whatever we are looking for. So we first need to understand what the mole is. Now, the mole is the number of an elementary particles that is equal to the number of carbon atoms in 12 grams of carbon-12 isotope. Pretty much what they're trying to say that 1 mole is, if you're looking at relative to carbon, carbon has 12 grams of it. So 1 mole, 12 grams, therefore it's relative to that over there. Or you can think of it like this, that 1 mole in any element, in every element, contains 6,02 times 10 to the power of 23 atoms. So it doesn't matter what mole. If you have 1 mole of hydrogen, 1 mole of helium, 1 mole of lithium, it doesn't matter. Whatever mole you have, they will always have this amount of atoms in 1 mole of any element that you are looking for. Doesn't matter what element it is, this will have 6,02 times 10 to the power of 23 atoms inside 1 mole. Now, this number would also be known as your Avogadro constants. So if we're talking about this number over here, this number is also known as my Avogadro's constant over there. So let's look at this over here. I've got carbon here, carbon 12 grams of it. If I have 12 grams of carbon, it means I have 1 mole. 1 mole over there, which is still going to give me Avogadro's constant over there. If I have zinc, if I have 65 grams of zinc, I have once again 1 mole, right? And this amount. Now, this one over here, remember zinc over there, 65, and where are you going to find the 65 over there? The 65 will always be found on your periodic table. So if I look at this over here, here is my zinc over here, 65. 29, 30, element 30, 65 over there, 65 grams. If I have 18 grams of H2O, that means over here, in my 18 grams of H2O, this over here, all of this represents 1 mole. And all of this inside over here is going to contain my Avogadro's constant in terms of elements. Now, how did I get this over here? Remember, H is what on my periodic table? My mass is going to be 1. And oxygen is going to be how much? 16 over there. So if I look at that H2O, remember, it's going to be 2 times 1 plus 16, which is going to give us 18 grams over there. 2 times 1, why? Because I've got 2 hydrogens. 2 times 1, 1 oxygen plus my 16. Or I can even say 16 times 1 is still going to give me that. So here, we're looking at the mole. Doesn't matter what it is over here. I have 1 mole of each one because each one's mass is exactly that over there. So when I say that carbon over here, it's going to be carbon. Here's carbon, 12. So if I have 24 grams of carbon, that means I have 2 moles. Because I'm going to say, 24 divided by 12 is going to give me 2 moles. Right, so the next thing that we're going to look at over here is your relative molecular mass over there. So this is the mass of 1 molecule of a covalent substance relative to the mass of 1 atom of carbon-12. So we keep on using carbon-12 is just the scientists, the element that they decided to choose. All right, so you'll see carbon-12 everywhere. So the symbol for relative atomic mass is going to molecular mass. Is going to be symbol is going to be Mr, and the unit is going to be AMU. But if we're looking for our molar mass, just our molecular mass, it is going to be your grams per mole. Right, I'm going to do both at the same time since it's so similar. The only thing we're pretty much changing is our AMU to our Gmol over here. So if we look at H2O over there, I've done it for you. 2 hydrogens and oxygen gives us 18 AMU. If we look at our next one over here, we've got CO2, carbon dioxide over there. That CO2 is going to give you what? 1 carbon is 12, 2 oxygens over there, 2 times 16 is going to give you your 44 AMU. Now, if I ask you, please calculate the molar mass, instead of 18 AMU, I'll have 18 G mole. You can see I've written it to the -1. It's the same thing as this over here, right? Because this will be grams per mole like this over here. And remember, when you want to write it like in one line, it'll be written like that. And if I also asked you to please calculate the mass, the molar mass for this, so it'll be my MCO2, that is my molar mass over there. It's still going to be what? 44 G mole over here, right? So I'm just working with both at the same time, killing 2 birds with 1 stone. Next, I've got these ones. You can pause it, try it out, do it by yourself, right? Hopefully you have done it by yourself and pause the video, right? So your first one for SO3 would be 80 G mole or AMU, depending on whether you used your relative molecular mass or your molar mass. Your next one for 2H2S, 34. Next one for 3 ammonia, is going to be there your 17 G mole, and then your next one over there is going to be your 46 G mole. Right, the next one here, I'm going to ask you to please calculate the molar mass for this one over here. Right, hopefully you pause it and have done it yourself. Calcium, 40, remember where you get your calcium from. The calcium over here, 40, right? Then NO3, you can see here, because there's a 2 on the outside, that means 2 times 1, it's going to give me 2 nitrogens, 2 times 14. Oxygen, there are 3 oxygens over here, but this 2 is here, so that means the 2 times 3 is going to give you 6, so 6 times 16, which is going to give you 40 plus 28 plus 96, therefore it's going to be 164 G mole. If you calculated, which you shouldn't have, and I asked you to calculate in your molar mass, it's supposed to be G mole, but if you did relative molecular mass, you would have 164 AMU. Right, so this is pretty much the basic, and think of all of this over here as a constant, because all of this over here can be found on your periodic table, which means you should always be able to solve for any of this that we are giving you. Because the next one that you're trying to do is going to be this over here. Your formula, N is equal to M over M. Your N is your number of moles. Your M is your mass, which is in grams. And your capital M over here is your molar mass, which is your G mole. And we know how to calculate your G mole. Right. So, if I ask you to calculate the number of moles, for example, calculate the number of moles of copper. Calculate the number of moles of copper there are in a sample of a mass of 127 grams over here. So already we've got a mass. They're asking us to calculate the number of moles, which is this over here, and we always have our molar mass. Our molar mass for copper, if we look for copper, Cu is 63,5. Right, so we've got everything that we need to solve for that over there. So N is equal to M over M. Yes, I've put that for you already. And that's going to give us 127 divided by 63,5 G mole. Right, I always want you to put in your SI units. Make sure you put in your SI units so that you don't forget, because if you do not put in your SI units, your answer will automatically always be wrong. So our number of moles, how many times does this go into that? 2 times. So our number of moles is equal to 2 moles. And that is your answer. Next one over here. But, sorry, just something extra. If they ask you to calculate the number of atoms there are in 127 grams of copper, the amount of atoms. Remember, 1 atom is equal to Avogadro's constant, which is this over here, 6,02 times 10 to the power of 23. So I can take these 2 moles over here, and I can say 2 times 6,02 times 10 to the power of 23. I can put that into my calculator over here. 2 times 6,02 times 10 to the power of 23. And that gives us over here 1,204 times 10 to the power of 24 atoms. This is how many atoms there are in this. Right. So if ever they ask you to find the amount of atoms, all you need to know is the number of moles, then just multiply it by your Avogadro's constants. You can already see how important this N is going to be in whatever we are doing. Right, the next one they ask us to do, calculate the number of moles in one kilogram of MgCl2. Right, magnesium chloride over there. So the first issue, this 1 kilogram, you can see here that my SI unit has to be in grams. So this 1 kilogram is incorrect. We need to convert it to grams. How many grams in a kilogram? 1,000. So it's going to be 1 times 1,000, which is going to give us 1,000 grams. Right. Now that we've got this, we also cannot just pull it straight from our periodic table, MgCl2. We need to calculate the molar mass. And you have done it in the previous ones that I've just done with you now. Right. So we're going to calculate this over here. Our molar mass, Mg is 24,3. Our Cl is going to be 35,5, but we have two of them, so it's 2 times 35,5, which is going to give us 95,2 Gmol. Because I've got my 95,2 Gmol over there, now that I've got that, I can use that formula over there. N is equal to M over M, which is going to be 1,000 over 95,2 G, which is going to give us 10,5 moles, right? And that is your introduction into quantitative aspects. Your moles, what they represent, how to calculate your molar mass, and yeah, Avogadro's constants. Thank you very much.